Good day, learners. You are here to check your solution on solving vectors. Now let's check it. But before that one, let us have a quick discussion on the difference between a scalar and vector. When we say scalar or scalar quantity, it only have a magnitude, while vector quantity has both magnitude and direction. Both scalar and vector quantities share magnitude, but for vector quantities, it do have a direction. What are the examples of scalar quantities? We have here the length, area, volume, speed, mass, density, pressure, temperature, energy, entropy, work, and power, on which it only have magnitude. In the other way, vector quantities examples are displacement, velocity, acceleration, momentum, force, lift, drag, thrust, and weight, which most of them or all of them do have magnitude plus direction. Vectors is very important in able for us to get or to determine a particular direction as shown on the picture below. In relation to that, in relation to direction, we have here two terms that is very familiar to us, which are distance versus displacement. Now let us know about distance. To recall, distance is a scalar quantity that refers to how much ground an object has covered during the motion. Again, it is a scalar quantity. It only have magnitude, but it do not have a direction. In the other way, displacement is a vector quantity that refers to how far out of place an object is. It is actually the object's overall change in position. Now, in able for you to understand more about distance and displacement, I want you to refer and look at the picture given on the left side of this PowerPoint presentation. There are four questions to answer. To start, we have the first question. What is the distance traveled from point A to point C? The correct answer is 7 and not 5. Why 7? It is because we are talking about the distance. We are talking about how long or how much did the travel occur or the object has covered on the ground. If you will look on the picture, it determines and it points on letter A to B, which is 4 meters, and B to C, which is 3 meters. If you will add 4 meters and 3 meters, if you will sum it up, it will give you 7 meters. Second question. What is the displacement traveled from point A to point C? There is a cue there that it would be 5 meters. Why it is not 7? Again, we're talking about displacement, which is a vector quantity. It refers to how far out of place an object is. So that determines to the beginning to the end point of the particular object. So we have there the displacement measured by 5 meters in color black arrows. Number 3. Based on number 1, if he goes back to the point of origin from point C, what will be the total distance traveled? The correct answer is 14 meters. It is simple to add everything from point A to B, then point B to C, which is already 7 meters, then going back from point C to B, that's another 3 meters, and B to A, that's another 4 meters. To sum it up, that is 14 meters. Number 4. Based on number 2, If he goes back to the point of origin from point C, what will be the total displacement? There is a cue that it should be 0 meters. Why is it 0 meters? Because when an object goes back to the point of origin, it means it haven't go far out of a place of origin, giving you only 0 or no meters or no displacement at all. Now let us check your understanding between scalar and vector quantities. There are four statements being shown here on the screen. First statement, that region is 10 kilometers north from here. Is it a scalar or a vector? It is a vector. It is because it do have a magnitude and also direction. 10 kilometer north from here. Now let us have the second statement. A car is traveling along a freeway at 100 kilometer per hour. Is it a scalar or vector? It is a scalar because it only have magnitude, no direction at all. Third statement, that region is 10 kilometers from here. Again, that is a scalar, only magnitude is being presented. Fourth statement, a car is traveling east along a freeway at 100 kilometer per hour. Is it a vector or a scalar? Correct. It is a vector because it do have magnitude and direction at the same time. Now let us try your understanding deeply into these. This one is also found on the PDF presented on our MCM Digital and also on the presentation that we got on our discussion. Now, there are five following quantities you need to determine if it is a scalar or vector quantity. Now, in able for you to understand it deeply, you need to know about the units or the formula for each quantities. For number one, acceleration can be expressed to final velocity minus initial velocity divided by time, which can also be presented through these. Change in velocity over time, which the change in velocity or the velocity itself can be expressed to displacement over change in time. Since it used displacement to that extent, acceleration is a scalar quantity. I mean, a vector quantity. Why is it a vector quantity? Because it do have direction through displacement. Number two, mass. Is mass a scalar or vector quantity? We need to know about the formula of mass. Mass can be expressed through mass is equal to density multiplied to volume. It is very evident that there is no direction in this particular example, having mass as a scalar quantity. By the way, scalar quantity is expressed with S, red S, and vector quantities are expressed in red V's. The third one, weight. Weight can be expressed through the formula net force, which is also equal to mass multiplied to g, or the acceleration of the gravity. Now, now since gravity will pull a particular object in y-axis, there is now a particular direction, having weight as a vector quantity. Now for the force, force can be expressed through net force equivalent to mass multiplied to g, or the acceleration of the gravity. With that still, force is still a vector quantity. Lastly, temperature don't have any direction at all. It only have magnitude. With that so, temperature can be considered as a scalar quantity. Now this time, let us talk about the application of vectors. You are very good already in writing and expressing a vector. This time, let us apply those into such conditions. First is the vector addition. It is simply the addition of the vector. If two similar vectors point in the same direction, then you can add them. We have here as an example. A man walks 54.5 meters east, then another 30 meters east. You need to calculate his displacement relative to where he started. With that so, the arrow in blue expressed the man walking 54.5 meters east, while the arrow in red expressed the man walking 30 meters east. Since both of these particular arrows do have the direction of east, you can have or you can add them together, giving you a displacement relative to where he started. On the color violet arrow or purple arrow, you can see that it is now 84.5 meters east. We have just summed up the two arrows above. You need to notice the size of the arrow conveys the magnitude, and the way it was drawn conveys direction. So as you can see over there, the purple arrow is bigger than the blue and red arrow. Thus, it do have the same length when combined, the blue and red arrow when combined, because it is actually the summation of the two. If you would notice, blue arrow is longer than 30 meters east arrow or red arrow. It is simply because 54.5 meters east or 54.5 is a bigger value compared to 30 meters. In this application of vector, the size matters. Also, if you would notice, the arrow is facing east. It is simply because the direction must be going to the east. So as you can see, the head pertains to the end point of a particular direction, while the tail portrays the starting point of the particular direction. Again, the tail conveys the starting point of a particular direction, and the head of the arrow portrays the end part or the end of a particular direction. Next one is the vector subtraction. In the vector subtraction, if there are two vectors going in opposite direction, you may subtract them. Earlier, if vectors are going to the same direction, you can add it. This time, if vectors are going in opposite direction, you need to subtract it or deduct it. Now we have here an example below. A man walks 54.5 meters east, then 30 meters west. Calculate his displacement relative to where he started. We have known that this particular man started somewhere on the color blue arrow, particularly on its tail. Now he walks 54.5 meters east. Then, after walking to the east, he goes back 30 meters west. So you can the arrow in color blue is actually the 54.5 meters east, and the 30 meters west is expressed in red arrow. Now, since the two arrows are going in opposite direction, we can have vector subtraction, enable for us to calculate his displacement. Now, in calculating his displacement, we need to subtract the value of 30 meters to 54.5 meters. It will give you only 24.5 meters. Question: of to which direction should we follow? We need to follow the direction which has a longer or bigger value. We need to follow the direction of the arrow that do have a longer length, and also it is actually the same arrow on which there is a bigger value. With that, so in this case, east is longer, or the arrow that pertains to the east is longer and do have bigger amount than the arrow that pertains to west. With that, we have here our answer, 24.5 meters east. You are very good on subtracting and adding some vectors. Now, this time, what if it is not linear? Those examples earlier are actually linear vectors. It only plays on one axis. This time, we are considering all of the axes. We have there the x and the y. Now, when two vectors are perpendicular, you must use the Pythagorean theorem. If you have noticed, we have uploaded a review video on Pythagorean theorem and also on trigonometric functions on this particular lesson. Now we have here an example. A man walks 95 kilometers east, then 55 kilometers north. You need to calculate his resultant displacement. If you will draw an arrow from the head of the second vector to the tail of the first vector, you could create in total a shape of a triangle. Always remember the tail to head method. Go first to the tail of the very first vector, then connect it to the head of the very last vector. So if you will do that one, you could create a triangle. And we can solve particulars in triangle through Pythagorean theorem. If you can still remember the formula for the Pythagorean theorem, it will give you c squared is equal to a squared plus b squared. Or you could also express it in c is equal to the square root of a squared plus b squared. Now we have known that the longest arrow or the longest line pertains to the hypotenuse in this case. And hypotenuse is expressed in c, which is also our resultant displacement. So if we will solve this one, we have here the resultant, and we need to substitute the value. We have there resultant is equal to the square root of a squared, and we need to substitute the value of the adjacent over there, which is actually expressed on the formula a squared. So the value of the adjacent here is 95. So we have there 95 squared plus the value of the opposite, which is 55. So we have there 55 squared. If you will solve that one, it will give you the square root of 12050, or 12,050. And if you will solve for it, it will give you 109.8 kilometers. So this one would actually be your answer for the resultant displacement. That is if two vectors are perpendicular. Again, that is if two vectors are perpendicular. Now let us try your knowledge about this one in understanding. Now let's give it a try. Let us solve what is written and what is shown on the PDF on the last part of the PDF that we have given and uploaded. Also, it was being reminded through the video that we have made beforehand. Now, this sample problem is very simple. You just need to find the components of vector A, which is equivalent to 3.00 meter per second squared, 30.0 degrees north of west. Now, always remember that when we say components, it pertains to the a sub x component, or the x-axis component of A, and a sub y component, or the y-axis component of A. Now we need to use GRESA. Sir, what is GRESA? That is actually given, G for given, R for required, E for equation, S for solution, and A for answer. To start, let us have letter G, or the given. We have here the given. The vector A is equivalent to 3.00 meter per second squared, and the theta, or the angle, is equivalent to 30.0 degrees north of west. We have now the given. Now let us move on to R, or the required. As what I have mentioned earlier, we need to get the components of vector A. And when we say components, it pertains to A sub x and A sub y, or the x and y axis components of our vector A. Now let us move on to letter E, or the equation. Now we have known on the previous discussion and through the trigonometric function that A sub x cosine theta is equivalent to A sub x, or the x component of A, while A sub y sine of theta is equivalent to A sub y. You may understand that one if you will draw the particular problem first, enable for you to know which is the hypotenuse, opposite, and adjacent. But if you have already seen the examples given, you will know that this would be the standard equation. Now this time, let us move on for S, or the solution. Now you may draw a free body diagram, enable for you to understand it more as what I have said. So we have here the vector A, which do have 3.00 meter per second squared, and actually expressed with an angle of 30.0 degrees angle north of west, which is also shown on this picture. So we have there y-axis and x-axis. You just need to understand the direction. So as you can see over here, you can verify it is actually north of west. Now this time, we need to solve first for the x component of the vector A. And able for you to solve that one, you need to use the equation given, or the equation that we have written a while ago. So that is A sub x is equal to A sub x cosine theta. Now we have known that the angle of this particular example is 30. But we could not simply put 30 over there because we need to consider the particular vector in relative to x and y axis. Since in this particular example, the vector goes 30.0 degrees north of west, we need to consider the complementary angle of 30 degrees from the x-axis to the particular component of this particular vector. With that so, we have known that the straight angle will give you 180 degrees. And we need to deduct the given 30.0 degrees, enable for us to know the complementary angle. So it should be 150 instead of 180. So we have there, we need to substitute the value of A sub x in this particular problem. So we have here 3.00 meter per second squared cos 150 degrees. It should not be 180 because we need to deduct the 30 degrees angle to 180 to get the complementary angle of this particular straight angle. Now, if you will have that one on your calculator written, it will give you a total of negative 2.60 meter per second squared. So this will be our x component or x-axis component. Now let us solve for our y-axis component. Now, still, we will be using the particular equation that we have written a while ago. So we have here a sub y sine. So we have there the complementary angle. You just need to deduct 30 degrees angle from the 180, which is coming from the straight angle. So it will give you 150 degrees. So if you will substitute the value of a sub y, you will have 3.00 meter per second squared sine 150 degrees. So it will give you 1.50 meter per second squared. So that will actually have the y component of this particular vector. So, do not forget to re-express your answer because the last part of Gresa is letter A, or your answer. So we have here your answer. A sub x is equal to negative 2.60 meter per second squared, and A sub y is equivalent to 1.50 meter per second squared. So these are the components of our vector A. Congratulations, you got it right. Now, this time, I'd like you to again tickle your brains through our sample problem number 2. Now, for our sample problem number 2, here is the problem. Find the x and y components of a displacement vector with a magnitude of 10 meters and direction of 40-degree angle with respect to the x-axis. It is almost the same with the previous problem that we have. Now I'm giving you the answer for this particular problem. So I'll be going back again to the previous slide so that you may have a screenshot for this one. And at home, please try to answer this one. Already have the A of the Gresa, which is the final answer. You just need to write the G, R, E, and S, which are the given, required, the equation, and the solution. So, what is the answer for this particular problem? It should be for the x component of D, it should be 7.7 meters, while for the y component, we have there the 6.4 meters. Now, of to what would be the solution for this one? You may try this one at home, and we will verify that one back on our class next week. Thank you very much for listening. Hope you have got something from me today. And please continue solving and practicing at home through the activities and the problems that we have given through our MCM Digital. Thank you very much and have a great day. Congratulations as well. Thank you very much.